law of cosines, it's a way of solving triangles, except for law of sines, if we have an angle, a side, an angle on the side, or a side, and angle, then we could solve the triangle. So law of cosines you use if you have a side, angle, side. You remember that from geometry. Or side, side relationship. Then you can use the law of cosines to solve the triangle. Now what's nice about the law of cosines, you don't have that ambiguous case, so it's kind of nice.
Terrific.
Okay? So given any triangle, the law of cosine says that c squared equals a squared plus b squared. It's almost like the Pythagorean theorem. Minus 2 times a times b times the cosine of c. Do you guys remember this?
I do.
You've seen this before. Okay? So c, this little c, is always the side opposite this angle. Okay? And a and b are the sides that enclose, they're the sides of that angle. Okay? So this big, don't worry too much about the letters. Sometimes they write it in 3 different forms. Like they'll also say that b squared equals a squared plus c squared minus 2ac cosine b, right? Or they'll also say that a squared equals b squared plus c squared minus 2 bc cosine of a. Now don't worry too much about which letter. Yeah, I wouldn't memorize 3 different formulas. Just know that this angle is opposite this side, and these 2 are the sides of this angle, right? In other words, they're the sides that include that angle. So, for instance, let's solve a triangle. So I'm going to get my triangle drawing tool. There we go. You can do it.
You're so beautiful.
Thank you. Go ahead, get that. Okay?
Like magic.
And we need to change colors because it's not a very exciting color. This is 60 degrees. And even though it doesn't look like it, we'll call this side 2. And we'll call this side 3. And they will say solve the triangle. Solve the triangle. Okay, which means find all the sides and all the angles. All right? You've done this before? Have you done this before?
Yeah.
So this thing, probably in geometry. So this is the side we're going to look for first. I don't know. Let's call this side C. Let's call this angle C. Let's call this A. Let's call this B. Just for that. So, you know, based on this, the law of cosines, that c squared, it's almost like, it's almost like the Pythagorean theorem, right? But if this angle is an acute angle, then you're actually going to be subtracting something from the Pythagorean theorem. And if this angle is an obtuse angle, you're going to be adding something to the Pythagorean. You understand? Because if it were a right triangle, then it would be this squared plus this squared equals this squared. But since this angle is less, you have to subtract something, and that thing that you're going to subtract is 2ab cosine c. And then you're going to be, if this angle is an obtuse angle, you're going to be adding something, which is also minus 2ab cosine c, and you can say, how can I subtract something? I'm actually adding something. Because what's the cosine of an angle bigger than 90 degrees? Is it negative or positive? It's negative, right? So you're going to have a negative negative, so you're actually adding something when this angle is bigger than 90 degrees. So here we have c squared equals a squared, which we'll call 3 squared, plus b squared, which we'll call 2 squared, minus 2 times 3 times 2 times the cosine of 60. Well, I'm going to run out of room. That's okay. So now I know that c squared equals 9 plus 4 minus, multiply all this stuff together. Don't do the mistake of doing the order of operations wrong. First you have to multiply all this junk together, which is 2 times 3 times 2, which is 12, times the cosine of 60. Anyone remember what the cosine of 60 is? That comes out exactly as something. It's 1/2. Okay? So this problem is set up so that it works out nicely. Won't always work out nicely like that. Don't go 9 plus 4 minus 12. Because this 12 is attached to this 1/2 by multiplication. So you get that c squared equals 13 minus 6, right? So c squared equals 7. So c equals the square root of 7. So that's that side over here. Square root of 7. Okay? It won't always come out to be a nice, beautiful answer like that. Okay? Now we got to find an angle. All right? And you could try to use a lot of signs, but that's not really. Is it going to work?
Yeah.
Sine of 60 is to 7, and sine of A is to 3. You could do that, but then you have to worry about the ambiguous case and all that stuff. So let's find an angle. Let's find an angle using law of cosines. You want to find B over here? Okay. So in order to find B, what I have to do is go, let's see, this is B. So we know this is root of 7. So we're going to go 2 squared, which is side B, which is all by itself, equals the side surrounding that angle, 3 squared, plus root of 7 squared, minus 2 times 3 times root of 7 cosine of B. And I'll give you a way to kind of shortcut it after I talk about this. So now what I do is I square everything, so I get 4 equals 9. What's root of 7 squared? 7 minus 6 root of 7 cosine B. Okay? And again, don't make the mistake of trying to put all these 3 things together, because you can't do that. First thing you have to do is go 4 equals 16 minus 6 root of 7 cosine B. You still can't put these 2 things together because these 2 things are attached by multiplication. So first I have to subtract the 16 from both sides. Minus 16 minus 16. So I get minus 12 equals minus 6 root of 7 cosine B. And now I divide by negative 6 root of 7. So when I do that, hey, slow down. I get negative 12 over negative 6 root 7, which comes out to be 2 over the square root of 7 positive, because I'm dividing a negative by a negative, equals cosine B. So then I take the inverse cosine of 2 over root of 7. And you don't have to rationalize that or anything, because so I'm going to go 2, clear, second cosine of 2 divided by the second square root, here, this one, square root of 7, close parentheses, oh well, I don't want to get rid of that. Over here, click to the right, and then close the parentheses. And then if I hit enter, I get that. So this angle here is about 40.9 degrees. And then you can just add up to 180, and that's 100.9. So this one up here would be, what's that, 79.1 degrees. Right? Okay? So that's how you use a lot of cosines to find an angle. Now, another thing that you can do, okay, is to, you can solve one of those equations for the angle. And if you do that, Can I get a new page now?
Yeah.
Sure. So if I do take, like, for instance, c squared equals a squared plus b squared minus 2ab cosine c. And I want to solve that just for c. Angle C is equal to a square inverse cosine of a squared plus b squared minus c squared divided by 2ab, because the signs kind of flip, so this whole thing would be in parentheses. So it'd be inverse cosine of a squared plus b squared minus c squared over 2ab, if I solve this equation for c. So you can do it that way, or you can just use the original formulation.
Would it be a worthwhile investment of our time to memorize that second thing?
The second thing, well, you could derive it pretty easily. I guess if you want to, it's just the inverse cosine of the angles of the side surrounding the angle squared minus the side opposite the angle squared divided by 2 times the angles, the side surrounding the angle.
I was just wondering if you think we should take the time to memorize that.
I don't think so. I never have. Okay? I never have, and I've gone far with my mathematics. Not really, not that far. Not nearly as far as some of you will go.
I bet you could make like a comedian show on a kids channel for teaching them math and making them laugh.
I could. Math with laugh. Laugh with math.
Yeah.
We could call it. Okay. That would, okay. Okay. 3, 4, 6. I'm not going to do this whole thing, but in the case that you do have just a bunch of sides, and they say solve the triangle, let's just say that I want to find one of the angles.
Wait, didn't we basically just do that with the last one?
Yeah, I guess we basically just did
But
do
we
that.
had an angle.
So
We did it again.
let's just say we're trying to find angle A up here, okay? So angle A, I'm going to just use this formula, except we're going to switch things around. Angle A is equal to the inverse cosine of the 2 angles surrounding angle A, which in this case I'm going to call 3 squared and 4 squared, right? Minus c squared, which is 36, over 2 times 3 times 4, right? So I'm going to get that angle A is equal to the inverse cosine of, what's 3 squared and 4 squared? 9, 16. That's 25 minus 36. What's that, minus 11? 16, 9, 16. And 9 is 25 minus 36, so that's negative 11 over 2 times 3 times 4, that's 6 times 4, which is 24. And you can take the inverse cosine of a negative angle. You're just going to get an obtuse angle. So if I go second cosine of negative 11 divided by 24, I'm going to get that this angle up here is 117.27. Right? Did I do that right? I did. Okay? And then to find this angle or this angle, then you don't have to use law of cosines again. You could just use law of sines, because once you know that this is an obtuse angle, right, there's no more ambiguous case. So you can just say, we'll call this B, that sine of B is 2, 4, as sine of A, sine of, so in this case you don't want to round off too much because you're using your rounded off number to begin with, is to 6, and then you would get that angle B I'm not going to do it all out. 26.4, you guys get that? 26.4, I believe. Angle B, oh no, angle B comes out to be 36.3. 36.3, and then subtracting from 180, you would get that angle C over here would be about 26.4, somewhere in that range. Okay? Questions about law of cosines? It's law of cosines is kind of easy. It's just doing the algebra. A lot of people make mistakes with that. Okay? Now we have a navigational problem. You ready for a navigational problem? Sure you are. Okay? So let's see if I can find it. Wait. We better. So here we have a navigational problem. A motorized sailboat leaves Naples, Florida, bound for Key West, 150 miles away, maintaining a constant speed of 15 miles an hour, but encountering heavy crosswinds and strong currents. The crew finds after 4 hours that the boat is off course by 20 degrees. How far is this sailboat out from Key West at that time? Through what angle should he go to correct his course? How much time is to be added because if the trip is to remain constant? Okay, so let's see if I can do this. I will just do one piece at a time.
Do you need to tell us how to do something new, or is this basically just like an application of what we know?
It's an application, but it's a little tricky to draw the picture. Okay, so so here is your. If you were going straight up this way, he would go that way, but he's not going straight up that way. He is going leaves Naples, Florida. So here's Naples, and bound for Key West. He wants to go. He wants to go over here. Let's pretend that this is Key West, even though I guess he should really be going south.
Keystone.
Right? Key West. Maintaining a constant speed of 50 miles an hour. The crew finds that the boat is off course by 20 degrees. So what happens is he goes off course by 20 degrees this way. Okay? So this angle right here is 20 degrees.
Wait,
What?
wouldn't it be the...
Doesn't matter. Okay? It doesn't matter. It just says he's off course by 20 degrees. So he could be on this side or that side. Doesn't
I
matter.
meant like
Oh, down this way?
like 20 degrees. Before you start.
No, because this is where he start, right? And he's meaning to go this way, right? But he's blown off course by 20 degrees, okay? Maintaining a constant speed of 15 miles an hour, when covering heavy crosswinds. The crew finds after 4 hours that the boat is off course by 20 degrees. So if he goes for 4 hours at 15 miles an hour, how far does he go?
60 miles.
60 miles, right? So what they want to know in this case is 15 miles. Oh, and Key West is 150 miles away. So if he went on course, he would go that way. And what they want to know is how far is it from here to here, right? So you could call this like X, right? So again, you use the law of cosines. X squared equals 150 squared plus 60 squared minus 2 times 150 times 60 times the cosine of 20. Okay? And plugging that all in, x squared. I did this somewhere. X squared, I don't know what it is, but x comes out to be, I don't have to do this, do I? About 95.86 miles. Okay? If you did this. So this is 95.86. And then the next part of the question, going back to where I was, whoops, where'd it go? It says, through what angle should the sailboat turn to correct its course? Got it? So going back, he wants to know really what this angle that he needs to turn is, right? So really what you have to find this angle and then subtract that angle from 180 degrees. So in this case, let's do law of cosines again. We'll call this like angle C over here. This, the inside angle.
Could you just do the?
Law of sines? You could, but then you're going to have ambiguous case because you don't know whether this angle is obtuse or acute. You see what I'm saying? So you have to do two different possibilities. So I would not. Guys. And if you do law of cosines, you get that. Let's see. Angle C. So angle C is going to be equal to the two sides surrounding it, right? 95.86, or the inverse cosine of this mess. 95.8 squared plus 60 squared minus 150 squared over 2 times 150, whoops, 2 times 60 times 95.86. And if you do that on your calculator, let's see that, you're going to end up with about a pretty small angle. Pretty small angle or pretty big angle? Oh, you actually get a pretty big angle, which is 147.2 degrees. So this angle here ends up being 147.2 degrees. So to find the angle that he needs to turn to, you would take that and you would subtract it from 180. 180 minus 147.2. And you, how much? 32.8 degrees. So he needs to turn 32.8 degrees to head towards Key West. Okay? And then the next question says, how far did he go out of his way? Well, if he went 60 miles this way and 95 miles this way, he went 155.86 miles. So how many miles did he go out of his way?
5.86.
He went 5.86 miles. No, it's not that many. Okay, so he only went off course by 5.86. And then they say, how long will it take? How much time did he mess up? Well, it goes 5.86 miles at 15 miles an hour. So you would take divide that by 15, and you get 5.86. 5.86 divided by 15. He went 0.39 hours, which is times 60. The 23 minutes and 44.44 minutes. 23.44. Okay? That's my thing. All right. So your homework class is page 546. 546, 1 through 9. Oh, not 1 through 9. 15, 23, 31.
1 through 9.
1 through 9. 31, 34, 35, and 39.
What?
Yay. And remember, you heard it here on Mr. Leader's Leader's Edge Math Channel.